Hello liners, thank you very much for your company. Welcome back to your channel, Transmission Lines Engineering TV. Previously, we have talked very extensively about the survey of a transmission line with manual methods of precision, such as a total station, which, by the way, it is an equipment which encloses its very own history. Technology changes and never stops, and the survey methods are not the exception. Digital topography is not really as recent as you think. Its history originates in the early 1960s. We will talk about very generally what LiDAR is and then explain how it works for the information filtering and how it is analyzed and proceed to reach the final product, which can be worked on PLSCAD or other software capable of handle data analysis based on LiDAR. LiDAR are the abbreviations of light detection and ranging, based on a high-speed scanner which emits an incredible number of light beams per second in different directions, so that the equipment is able to cover a wide ground extension. Now, there are several types of LiDAR. We do have air LiDAR, which is commonly used for transmission lines applications, and substations, which is mounted on an aircraft. But there is also land LiDAR, which is mounted on top of any vehicle, or submarine LiDAR, which is very useful for the analysis of submarine transmission lines. How it works. At least for our interest case here in this video, transmission lines and substations, there are several LiDAR service providers in different countries in the market, and depending on the extension of the transmission line, the provider will decide the type of aircraft, either be a helicopter for short lines or aircraft for longer lines. Likewise, there are several LiDAR scanner manufacturers, which all of them works on the same principle. As the aircraft flies over the alignment of the transmission line, the scanner emits a light beam which stops to detect any object on the ground surface. It might be a point on the ground, vegetation, cable, structure, anything. The light beam travels back to a device scanner called a detector. So this sensor will measure the time it took to make the wave from its initial shot to detect and return the wave. With the recorded data, the scanner will be ready to emit the next beam of light, and the process is repeated over and over again, thousands of times at an incredible speed. Depending on the services requested, other types of scanners can be mounted on the aircraft, such as an aerial photography and thermal survey for existing cables to later know the ampacity and temperature of the existing cables during the flight. And as a result, you get a series of reading points which contain information about the coordinates and elevation. For its analysis, an identification code is previously created for different types of points: vegetation, terrain, cables, structures, etc. The analyst will filter these points to assign their respective code depending on what it is involved, and assign a specific symbology and color to differentiate from others. This is an extremely amount of labor which demands a lot of concentration and knowledge. As a tool for the analyst, aerial photography is available for the identification of these points. Each point code is placed on a different layer to make easier its visualization. Another important point is the capacity of the computer to be used. A LiDAR file containing thousands of points requires very fast processors and very powerful graphics card. I recommend having a graphics card with double fan, since cards with a single fan they can become overheated, and this is why the computer gets frozen and sends the message that the software has stopped responding. As a computer, for these kind of applications, I prefer the usage of a desktop and not a laptop. The laptop is fine, but once the raw data LiDAR has been processed, unless it is a laptop with a very powerful graphics card. Now, photogrammetry. It is of great help because the images quality is much higher than the images we get by any free mapping system, such as Google Maps or Google Earth, for example. The reason is because these images are taken via satellite, which doesn't have a good resolution, since they have to pass through all the layers of the Earth's atmosphere. And on the other hand, the positioning has certain margin of error, which for certain applications it is really considerable. Photogrammetry, when taken from a few meters above ground, has both better resolution and positioning accuracy, and if these images are mounted as a layer on a LiDAR file, the results are simply spectacular. With a LiDAR survey, it's not required that the staff is in danger when accessing difficult areas. The number of points recorded is much higher than those taken with a total station, and you can have a three-dimensional model of the line alignment with all the details throughout the length of the right-of-way, and have a greater precision in the structure's locations to spot them on points where the geography of the terrain is the most favorable, and in addition, to have a better evaluation of the side profiles and error obstacles. In addition to the evaluation of ground clearances, it is possible to evaluate which sections of the existing vegetations endanger the transmission lines and determine in which points these trees will have to be trimmed. In the case of working with existing lines, it is possible to obtain the attachment heights of the cables on each structure, taking into account the existing heights, including the length of the existing insulator, is possible to model by means of PLSCAD. The existing cables can be modeled to match the points registered by the LiDAR, and by knowing the type of cable installed and the temperature, it is possible to calculate the mechanical tension of that particular cable at the recorded temperature to model the cable under different loading conditions. And in this way, we can get an idea of the tensions on the existing structures. Likewise, it is possible to evaluate in better detail other types of crossings, such as railways, rivers, in which it is possible to have a graphical data of the water levels and where it could climb up, to avoid placing structures within areas where the foundations might have erosion. LiDAR survey is a really breakthrough in modern technology. However, there are certain limitations that do not justify its use. For example, in a small analysis of substitution of distribution poles, for example, the distribution lines do not usually represent a topography problem, except for some locations, and they are short and easy to access. In these points, the cost of bringing an aircraft to survey a few meters of span is not economically feasible. In these very specific cases, it's much more economical to perform a survey by total station, since it's not necessary to survey as many points as for a transmission line. Well, this has been a description of LiDAR. Many people have heard about it, but in some countries it has not yet been implemented for various reasons. The most common is that there are no providers of these types of service in some countries, but it is a growing market, both as supply and acceptance. So to me personally, has given me very good results. So if someone asks me my opinion if they should be implemented, I will answer in the same way as I respond to something that I don't know. There's only one way to find out, and it is doing it. It is worth to investing in a pilot project to give it a try with a calculated risk. There is no other way. I hope this video has been able to give you useful information, especially for those companies, both owners of transmission lines and design contractors, to have a better vision of this technology and implement it. Maybe someone could think, and what's going to happen with the survey companies which only work with a total station? What's going to happen with those employees? As an answer, I could say, in my very personal opinion, a survey company will always be needed, including services with total stations. Always have the great opportunity to invest in this technology and update and expand its range of services. The surveyors and crew employed by these companies can invest in training their staff in this technology, so think about it. I hope this information is useful for you, which is the objectives of developing these videos. I invite you to visit my website, where in short there will be training courses online for many topics on the design of transmission lines. Thank you very much for your visit. Don't forget to subscribe and leave your comments on this video. So until next video, Transmission Lines Engineering TV, training to power the world.